Students, thank you for joining the session today. So today we will be seeing the topics of viewing and clipping in details in computer graphics. So these are the concepts that we will be going through. That is windowing concepts, clipping, introduction to the clipping, various algorithms, various approaches that are there. Area clipping is there and different algorithms under the area clipping. So beginning with that, we have the world coordinates. Now in world coordinates, a scene is there which is made up of collection of objects specified in world coordinates. Now here we are referring world coordinates to the coordinates of an object in the real world scenario. In a real life, the coordinates of that object are basically referred to as a world coordinates. They are specified in terms of x and y plane. That is, we are using the world coordinates in 2D plane. So when we display a scene, only those objects within a particular window are displayed. Now this is the window is there. Whatever inside in this window will be selected, that we will be transforming into the viewport coordinates. Fine. So we have the coordinates in terms of wx min, wx max, wy min and wy max. The alphabet W basically refers to the world coordinates. Fine. And whatever the object in the real world scenario will be selecting in this window, that will be basically transformed to the viewport coordinates. So now, because the drawing things to a display takes time, we clip everything outside the window. Now what this means is, outside this window everything will be ignored. Whatever the area of image we are interested in, that area basically comes inside this window, and outside this window everything will be ignored, and it is this part of the image which will be mapped to the viewport coordinates. Now the world coordinate area selected for the display is called the window. The world coordinate, that is the real life coordinates of the object, is basically the section of that object which is selected for the display. It is called the window, and where we are displaying it on some specific device, that area is basically referred to as a viewport. So that there is a mapping between the coordinates from the world coordinate area to the coordinates into the viewport area. That mapping has to be done, and then the transformation of image is there from the world coordinate systems to the viewport coordinate systems. So in in simpler terms, the window defines what is to be viewed, and the viewport defines where it is to be displayed. Whatever the area of the image that we want to display, that is selected, and that is basically referred to as the window area, and where we want to display it, that is basically referred to as a viewport area. So in computer graphics terminology, the term window originally referred to an area of picture that is selected for viewing. Fine. So in computer graphics, window refers to an area of picture that is selected for viewing, that is the area in which we are interested. So what we are basically trying to do is, there is one, just a second. We have this world coordinate system, and this is your world coordinate system, and on the right hand side we have the viewport coordinate system. Now this is the world coordinate system which we have discussed, and this is your viewport coordinate system. So here on the left hand side, this is how the object that appears in the real life. Obviously that has to be mapped on, when we want to display it on the device, it has to be transformed according to the coordinates of that specific device. So that's why there is a transformation of coordinates from the world coordinate system to the viewport coordinate system. So this is the general process how the window to the viewport coordinate transformation takes place. The point is there in the window, that is having coordinates xw and yw. Now this point in the window coordinate system has the coordinates xw and yw, and it is mapped onto the position, that is xv and yv in the viewport coordinate system. So to maintain the same relative placement in the viewport as it is in the window, we require that these equations to be equal. That is, the relative aspect ratio has to be equal between the coordinates of the viewport system and the coordinates of world coordinate system. So we have these equations being equal to the equations in the world coordinate system. On solving these equations, we will get the coordinates, the corresponding coordinate values for viewport coordinate systems. That is for x coordinate for the viewport coordinate system and y coordinate for the viewport coordinate systems. So these are the xv and the yv values that we will be requiring so that the mapping can be done. And here the scaling factors are there. Scaling factors according to which the image will be scaled down or scaled up in the viewport coordinate system. So the conversion from the window area to the viewport area is performed with the following sequences. So basically these processes are there when we do the transformation from window area to the viewport area. The first step is the scaling transformation is done with respect to the fixed point position of xw min and yw min, and then translate the scaled window area to the position of viewport. That is, first the scaling is done, scaling in or scaling out of the object, and then after the scaling is done, we translate that scaled window area to the position of viewport, because the coordinates are different in window area and the viewport. So accordingly that the image has to be mapped onto the viewport coordinates. So this is the basic process that goes on when we try to do the scaling process. So any procedure that identifies those portions of picture that are either inside or outside of a specified region of a space is referred to as a clipping algorithm, or simply clipping. Fine. The region against which an object is to be clipped is called a clipped window. Now the area of the image which comes inside this clip window, that is basically retained, and area of the image that is outside this clip window, that is basically ignored. For example, if this is a clipping window, now whatever will be there inside this clipping window, that will be basically retained, and whatever is outside this clipping window, for example this drawing is there, now this is outside this clipping window, this will be basically ignored if we are assuming that this is the clipping window. So everything inside this clipping window will be retained, and everything outside this clipping window will be ignored. So the image below, consider lines and points should be kept and which ones should be clipped. Now this is a reference diagram is there. Now according to in this diagram, these 2 points are there which are inside this window, so these will be retained. This point is there, P1 is there which is inside the window, this will be retained. P9 and up to this part of the line segment, this is inside the window, so this will be retained. And P4 is there, it is outside the window, so this will be ignored when we will be doing the clipping operation. And these again are your wx min and wx max coordinates, and wy min and wy max coordinates of the window area. So for the when coming to the point clipping, how we do the point clipping basically. So for the point clipping, simply some conditions are there. For example, a point is there having coordinates x and y, and for the point to is not clipped if x is less than equal to x min and it is less than equal to x max. For example, this point is there. So if this point is greater than this x min, greater than equal to this x min, and it is less than equal to wx max, that is, this point is there, this point, if it is less than this wx min and it is less than this wx max, and similarly it is greater than equal to wy min and less than equal to wy max, if the x and y coordinates of this point satisfy these four conditions, then this point will not be clipped. Similarly, for point P5 and P1, all these four conditions are getting satisfied. Basically, these 3 points P1, P5 and P9, they are coming inside this window, that is, they are satisfying the conditions of less than equal to wx min and less than equal to wy min, and also they are satisfying the conditions of less than wx max and wy max. So these points will not be clipped, and these points, that is P2, P4, P7 and P10, these are outside the window. So these are not satisfying these above conditions. So these points, that is P4, P2, P10, P7 will be clipped. That is, this is the simple procedure regarding the point clipping. If we want to do the clipping regarding some given point having some x and y coordinates, now for that these conditions have to be satisfied. If these conditions are getting satisfied, then the point is not clipped. If these conditions are not getting satisfied, then the points will be clipped. This was all about the point clipping. Now coming on to the line clipping, we have various scenarios when we come to the line clipping. Now scenario 1 is if the lines are inside this window. Now here in this diagram you can see that both the lines are inside the window, so there is nothing, no need to clip anything. Fine. And in this scenario, second scenario, we have one point outside this window and one point is inside this window, and similarly for this line you have one point inside the window and one point outside the window. So in this, some part has to be clipped, that is, this part needs to be clipped. We will see that how we do that. And the third scenario was both the endpoints outside the window. Now in this part also you have, in this line, that is in the third scenario, this point is also outside the window and this endpoint is also outside the window. So we need to clip some portion of this line, that is, this portion will be clipped and this portion will be clipped. Fine. So we'll be seeing in details how we'll be doing that. Now coming on to the line clipping, there are different approaches are there. First one is the brute force line clipping. Now the brute force line clipping, it can be performed as follows. Don't clip lines with both endpoints within the window. Now this is obvious. If the endpoints of the line, both the endpoints of the line are inside the window, then there is no need to clip anything. Fine. So that line is basically referred to as a visible line. So we don't have to clip anything. For lines with one endpoint inside the window and one endpoint outside, we need to calculate the intersection point using the equation of the line and clip from this point out. Now using this brute force method, if the some portion of the line is outside this window, then using the equations of the line we need to compute the intersection part of the line, and it basically involves extending the line to the to some outside extents of the window, and the complexity of when we are doing the line clipping using the brute force, the complexity of this approach basically does not favors our criteria. So that is the you can say that one of the cons when we use the brute force line clipping. Now again, in brute force line clipping, for lines with both endpoints outside the window, we test the line for intersection with all of the window boundaries and clip appropriately. So when we are doing the brute force lines, if there are too many lines, then we need to identify the intersection areas of all the lines with the window boundaries, and then accordingly we can further proceed to clip the parts appropriately. So the calculating the intersections is computationally expensive. That is here the complexity of the algorithm comes into the picture, and we need to have some favoring criteria when it comes to the complexity of the algorithms. Because the scene can contain so many lines, the brute force approach to the clipping is much too slow. Now this method basically goes easy when the number of lines given are less in number. But when there are too many number of lines, then this approach has got some cons on its side. Fine. So coming on to the next algorithm, that is Cohen-Sutherland clipping algorithm. Now this is as compared to the brute force line clipping algorithm. It is quite an efficient clipping algorithm. The advantage is that it reduces the number of line intersections that must be calculated. Now in the brute force line method, we needed to compute the number of intersections for all the lines, but in Cohen-Sutherland algorithm, the computations regarding computing the number of line intersections, that is basically minimized. Fine. So this was the Dr. Sutherland who developed this approach, and till today, nowadays, this approach is in use basically. One of the earliest algorithms with many, so this is about the Sutherland clipping algorithm. Some features are there. It was one of the earliest algorithms that came into the picture. Then processing time reduced by performing more tests before proceeding to the intersection calculation. Initially, every line endpoint is assigned a 4-digit binary value called a region code, and each bit is used to indicate whether the point is inside or outside one of the clipping window boundaries. So we will see that how we are doing it. So basically what is there in this is you have this window area is there, and you basically divide into this area into 9 regions. You basically divide the viewing area into the 9 regions basically. Suppose these are my 9 regions, that is this is the region 1 is there, this is region 2 is there, this is region 3 is there, this is region 4, this is region 5, this is region 6, this is region 7, this is region 8, this is region 9. So in Cohen-Sutherland algorithm, we divide our viewing area into the 9 different regions, and these regions are basically assigned some codes, and this is our region number 5 is our viewing area. Fine. So the number region 1 is assigned some codes, region 2 is assigned some codes, and this is basically done according to that TBLR notation that we use, that is top, bottom, left and right notation that we use in this, or we can use ABLR, that is above, bottom, left or right. Now this is region 1 is coming in the top, and it is on the left hand side, and for the right hand side its value will be 0. For bottom also the value for this region will be 0. Similarly for the region 2nd, the top value will be 1, the bottom value will be 0, right value will be 0, and left value will be 0, because region 2 is in the middle region. And for similarly for the region 3, the top value will be 1, the right value will be 1, the bottom value will be 0, and the bottom left value will be 0. So this is how we assign the values in for the different regions in the Cohen-Sutherland algorithm. So this is what we were discussing, that is top, bottom, right and left. For all the 9 regions, we kind of assign the values in terms of top, bottom, right and left. For this ordering, bit 1 references the left boundary and bit 4 references to the top one. So this ordering of bits is there. The bit 4 refers to the top location, bit 3 refers to the bottom, bit 2 refers to the right, and bit 1 refers to the left. A value of 1 in any bit position indicates that the endpoint is outside of that border. A value of 0 indicates that endpoint is inside or on that border. So if the values are coming out to be 0, that is 0 values are there, then it will indicate that the endpoint, it will be either inside the window or it will be on the border. If the values are non-zero, then it indicates that endpoint is outside of that border basically. So here these regions are there that we were discussing. The 4 window borders create 9 regions. So these are the 9 regions that get created. The figure below lists the value for the binary code in each of these regions. Now these values are in terms of binary values. That is what we were discussing, the top and top, left, bottom and right values. So the endpoint that is below and to the left of the clipping window is assigned the region 0, 1, 0, 1. That is this endpoint that is below. Since it is below, this is middle, and this is top. Since it is below, so the below area is assigned the value 1, and since it is left, so the left area is also assigned the value 1. The top value is 0, and the right value is also 0. So accordingly, all the regions are assigned the values in the similar manner. Now for this, the values are 0. Why? Because in this, top is also 0 because this area is in middle region. Left is also 0 because it is in the middle. Right is also 0 because it is in the middle, and bottom is also 0 because it is not in the bottom and it is not in the top, and it is lying in the middle of the region. Now every endpoint is labeled with the appropriate region code. Now in the example we saw the different points were there. So accordingly, those points will be falling into one of these areas. So accordingly, these values will be given the values according to the top value or the bottom value or the left value or the right value. Now consider this P4 point. Now this is coming in the top region. This whole layer that is above WY max. This is coming in the top region. This whole region between WY main and WY max, it is coming in the middle region, and this whole area below WY min, it is basically coming as a bottom region. So for this point, top value is 1, left value is 0, bottom value is 0, and your this right value is 0. So accordingly, all these points are allocated the values. Now the lines completely contained within the window boundaries have region code 0000 for both the endpoints, so are not clipped. Now you are seeing this. This line is having the endpoints within this window, and these both the points are having values as a 0 values. Fine. So the endpoints which have both the endpoints, if have the value zeros, then it means that the line is completely lying inside the window boundary. Any lines with 1 in the same bit position for both endpoints is completely outside and must be clipped. For example, a line with 1010 code for one endpoint and 0010 for the other is completely to the right of clipping window. So that is this point 1 0 1 0, this point, it is outside this window, and 0 0 1 0, again this is also completely to the right of the clipping window. So this clearly indicates that both the endpoints completely lie outside the clipping window. Fine. So we can perform inside-outside test for lines using logical operators. When the OR operation is done between the two endpoint codes is false, the line is inside the clipping window and we save it. That is, when we do the OR operation, and after doing the OR operation, if the result is completely 0, then it will indicate that the line is inside the clipping window. And when we do the AND operation between the two endpoint codes and the result is 0, then it will indicate that the line is completely outside the clipping window, and that part can be basically completely ignored. So the lines that cannot be identified as completely inside or outside the window may or may not cross the window interior. So now this is for the scenario when both the endpoints are outside the window. Now those endpoints, it might be completely outside the window, or they might be going through the window portion. These lines are processed as follows. Compare an endpoint outside the window to a boundary, and if the remainder of the line is entirely inside or outside the window, then retain it or clip it respectively. Otherwise, we compare the remainder of the line against the other window boundaries. We continue the above steps until the line is either discarded or segmented inside the window is found. So until and unless we detect the intersection point at the border of the window, till then we need to repeat the above steps continuously. Once we get the point which is at the intersection of the border, then we can stop the process and continue to the next portion of the line basically. So we can use the region codes to determine which window boundaries should be considered for intersection. That is, to check if a line crosses a particular boundary, we compare the appropriate bits in the region codes of its endpoints. If one of these is a 1 and other is a 0, then line crosses the boundary. Fine. Now this is the example that is given there with respect to the Cohen-Sutherland algorithm. We have the line with having endpoints as P9 and P10. So we start at P10. From the region codes of the two endpoints, we know that line doesn't cross the left or the right boundary. Fine. So calculate the intersection of the line with the bottom boundary to generate the point P10. So these values which we allocated to these points, it will indicate that this point will not intersect this right boundary, and it will not intersect the left boundary. So we need to calculate the intersection point at the bottom boundary of our given window. So the line, when we do that, the new intersection point is generated, that is P10 dash, and then P9 to P10 gives us the line which is completely inside the window, and this portion will be retained basically, that is P9 and P10 dash. Now again another example is there, that is for the Cohen-Sutherland example. We have the point P3 and P4. We start at P4, and from the region codes of the two endpoints we know that the line crosses the left boundary, so calculate the intersection point to generate P4 dash. Now according to the values of this point, we can detect that it will intersect the left boundary and will generate a new intersection point, that is P4 dash. And now again that is P4 dash and P4 is corresponding to the values of these 2 points. We can completely come to the conclusion that point the line P3 and P4 dash is completely outside the window, so is basically clipped basically. Again, another example is there, the line P7 to P8. We start at P7, then from the two region codes of the two endpoints, we know that line crosses the left boundary. So calculate the intersection point to generate P7 dash. Since this is the point which was outside the window, so from this we need to generate the intersection point, that is P7 dash we generated, and from P8 also we need to generate the intersection point, that is P8 dash, and then from the values of P7 dash and P8 dash we can come to the conclusion that this part of the segment is completely inside the window. So further also we will continue because of the length of the videos. We will be continuing further. If you have any queries, I'll be sending the link, and you can post your queries on that link. Thank you.